Say again? In the cupboard at the back.
Is it gas on?
Yeah, one of the cupboards at the back. Morning, hi. Morning, everyone. Hi, George. Hi, Ella. How are we on this fine Monday morning? Morning, Miss.
You're right.
Yes, thank you. Superb. We're going to do a practical today, Miss. I've got a lovely assistant. Much better looking than Mr. Farr today. Miss Brownstill's with us today. So we're going to do two practicals, filtration and evaporation. Okay, so first thing first, we're going to start with filtration, just some keywords. Okay.
What's the title of the whole thing?
I've split my page into two.
Right.
And I've got filtration one side, evaporation the other. So the title at the start is filtration. Okay. So filtration is the title, guys. And we're just going to do some definitions. And then Miss is going to show us filtration. Okay. Yeah, we're going to do science today, and then maths afterwards. We swapped it around this morning. So, first keyword we've got is soluble. Okay, soluble. The opposite of soluble is insoluble. So, can someone comment below? What does soluble mean? Comment below. What does soluble mean? Or can you think of something that's soluble? Comment below for us what we're going for. Hi, Chloe. Okay, we do this in science. What's soluble? Able to dissolve. Good. So soluble means
like sugar.
It, yeah, can dissolve. E.g. salt, okay, or sugar. So it can dissolve, okay? It can dissolve. So what do you think insoluble means? This word is usually meaning the opposite.
So
okay?
Can't be dissolved.
Yeah, it can't means it cannot dissolve. E.g. bricks or sand.
Wood.
Wood. Okay? Something that can dissolve on something that can't dissolve. Okay? So soluble and insoluble. So to give you an example, glass of water. Okay? Here we have got some salt, which is NaCl, which is sodium chloride. Okay, so this is the salt. If I put some salt in there, okay, and get the spatula, and I mix that up, and you see the salt will eventually start to dissolve. Okay, what has happened is the salt has now formed bonds with particles in the water. Okay, it's still there, but it's dissolved. That is soluble, okay, because it's dissolved. Question, Miss, see if you can remember. Sodium chloride, is that ionic or covalent? Sodium chloride.
For 50-50, ionic.
It is ionic. Why is it ionic? Because sodium is a
metal and non-metal.
And chlorine is a
Non-metal.
non-metal. So that is ionic, whereas water is hydrogen and
Oxygen, which is non-metal.
Excellent. So therefore, water is covalent.
Covalent, because that's not.
Okay. So a little recap of bonding. So that is soluble because it dissolves. So the next two keywords are solvent and solute. Does anyone know what a solvent is? A solvent. Well done, Tom. What's a solvent? What is a solvent? I'll give you a clue. This beaker contains a solvent, but what is the solvent? Comment below. Excellent. So Ben's told me what a solute is. So the solvent is the liquid. The solvent is the liquid that is dissolving the solute. So a solvent is the liquid. Okay, therefore the solute is the solid that is being dissolved. Okay, so for example, salt plus water makes salt water. That's what I've just done here. The salt is the solute because it dissolves. The water is the solvent. Okay? Now you can do this with loads of different things. You could have milkshake powder and milk, strawberry milkshake. You could have hot chocolate powder and hot water, hot chocolate. You could have coffee beans, hot water. Coffee beans dissolve, the water's the solvent. You could have a bath bomb and some water. The bath bomb will dissolve in the water. Okay? So there are four keywords. Now we're going to have a go at filtration. Okay? And then we'll draw a labelled picture. So, Miss has got us the thing over there. Hi, Miss!
Hi, everybody. Hey,
Right.
Miss, you okay?
Right, so.
So, we've got your conical flask, we've got a plastic filter, and we've got our filter paper. And those of you who have me for science in Year 7, we did these separation techniques not long ago. So, filter paper goes into the funnel. Now, in here, we've got a mixture of, we've got water, we've got some salt, we've got some gravel, I think, and we've got some sand.
Shall we put some more salt in there?
Shall we, Miss?
Put some more salt in,
Let's
so you
go
can see.
mad today. Okay? So lots of salt is going in with this now.
There's a little spatula.
Thank you. And like Mrs. just said,
Sam Foster says, I can remember this, Miss.
brilliant, Sam. Fab.
Kuze remembers.
Good, Kuze. Brilliant.
And Luke.
So, we're giving it a good mix and we're helping that salt dissolve into the water. Now, what we're going to do is we're going to pour this through the filter paper and we're going to let it drip into the conical flask. Anything that is insoluble, that means it does not dissolve, should end up left on the filter paper. So, it's going to start slowly pouring this through and it will eventually,
You can see how dirty it is at the top, okay?
and we're getting some really clear liquid down at the bottom, aren't we, Miss, as well?
That's a huge difference.
Look how different it is, okay? So at the top is insoluble. And what does insoluble mean, Miss?
Can't dissolve.
Can't dissolve. And at the bottom is soluble, Okay, so that looks like pure water, but there's something inside that water. What is in that water? Anything that has
Dissolved. So salt.
dissolved.
You put salt
So
in it.
salt, exactly. Exactly. And here we've got the soluble, so the salt. Okay, so we're going to leave that going for a little bit. Miss will keep topping it up so we separate the whole of the mixture. Okay, so there's our mixture at the top. It's insoluble, and at the bottom we've got soluble. So we're going to draw a little picture and label it. Okay, let's wiggle over here. Okay, so first thing, I'm going to draw one of these. Okay. Comment below. What is this called? What is this glass?
Beaker?
Who can remember what Miss said this was called? Anyone remember?
Is it? She said conical glass. Conical,
Yeah,
is that right?
conical. It is a conical. It's called a conical flask.
Well
Well
done.
done.
People got
Okay.
that.
This is the conical flask. And there's the lid, the hole. Okay. Conical flask. Going in the conical flask is this. What is that called? Going into the conical flask. Anyone know? And it begins with an F, Miss. What's it? What is it?
I was going to say filter, but then I was getting confused with
Oh.
paper. But
Yeah. What's the filter paper go in?
so is this the actual bit is the filter, and then you have filter paper, or is it?
Yeah. So
funnel?
this is the funnel.
Ah,
This is the funnel. Okay. Well done, Theo. And then inside the funnel, you have filter paper. Okay. You can do this at home with kitchen roll. Kitchen rolls are quite a good filter paper.
Coffee filters.
Yeah.
I've used coffee filters.
Coffee filters, Miss says, as well. Pair of socks. Okay. Filter paper, you can use kitchen roll at home, or pair of socks, or filter paper if you use coffee. Okay. So we've got a filter paper, our funnel, and our conical flask. Now, when we do filter, it separates into two things. One at the top and one at the bottom. Okay? So we'll start with the top. What is left at the top? What is in there? What is at the top? Why is it brown? Okay? We have sand and water mixture. Okay? Yes, Lucy, good girl. It's insoluble at the top. Insoluble. Okay? Where at the bottom, we have salt. Well done, Josh. At the bottom, we have salt water. Lovely.
that's the soluble bit.
And that's the soluble bit. Okay? So, why do we use filtration? Why do we use filtration? Filtration is used. Why do we use filtration? Comment below, or if you have any ideas, Miss, what do we use filtration for?
Clean water, I presume.
So if we're cleaning the water, what are we wanting to do to the water?
Remove all the bad stuff.
Yeah, so remove, we
So
use the word
filter.
separate.
Separate.
Okay, so today it's all about separation techniques. Filtration is used to separate insoluble. Okay, yes, excellent. So to separate two things, filtration is used to separate. But what are the things we're separating? Insoluble from soluble. You can only use filtration to remove insoluble from soluble
Got it.
particles or mixture. Okay, is it nearly done?
Not far, Miss.
Nearly done.
You can see bits of it that's already starting to settle on the outside.
Okay, and then just look how clear and clean that is.
Yeah.
Okay, so you'd use it, e.g., just like Luke said, salt water and sand. Okay, because it would take the sand away from the salt. You could use it to separate bricks and water. Okay, so nearly done, and then we'll separate the next bit. So if you put that onto that one,
yeah,
quickly,
there we go,
and then we can use this. Right, so that is filtration. Okay, next thing we're going to do is evaporation. Okay, so what are we left with? We are left with this. Okay, we are left with a lovely, oh actually, question. Look through the water, Miss Robson.
Yeah.
What can you see of the picture of the chairs? Why do the chairs look different in the water than they do outside of the water? What's it called?
I'm going to say refraction.
Refraction, well done. So if everyone looks, can you see how the chairs look different through the water than they do when you look at the side of the beaker? That's because of refraction. The light is going through the water and it's changing direction, so that's why they're upside down and look different shapes. Okay, that's refraction.
Thing, isn't it?
Yeah. Whereas the chairs are not upside down. When you look at them through here, they're upside down. Okay. So evaporation. Okay. So here we've got set up. Miss is going to talk you through what is happening, and then we'll draw a diagram.
Okay, so now we've got our clear liquid that's just come out of filter paper. We've got all of the insoluble material left on the filter paper, and we've got water and something else that's dissolved into the water. When we do this next technique, which is known as evaporation, we're going to find out what was dissolved in the water. So I've got a big dish here that's known as an evaporating dish. It's got a big wide open area to give plenty of space for the water to evaporate off. We've got a gauze which protects the bottom of the evaporating dish. We've got our Bunsen burner, we've got our tripod, and we've got our heatproof mat, and we've got our goggles on. So I'm going to pour this liquid, some of it, into this evaporating dish. Now, I'm going to rest that evaporating dish when I know it's secure, like that. Then I can start to light my Bunsen flame. Okay, so we'll put the gas on.
You can hear it hissing.
Is it on?
I could see it just before.
Yeah, it was on. Let's try again. Didn't want to light that time.
Let's have
No.
another go. Oh, have we picked the wrong Bunsen burner?
We'll go and get another Bunsen burner.
Right.
Always happens, don't worry.
Yeah. Some of the Bunsen burners, the pipes get blocked, or they get a lot of soot in the Bunsen burners, so you can't get the gas coming through. So we'll try one more. Who can remember what gas comes out of here? Begins with an M.
Methane?
Excellent. Methane.
I was talking to Miss this morning about the experiment we did, and I said magnesium bubbles. But
Come on, gas.
Yes, I can't hear the gas. Can you?
I haven't put the gas on. Well, that's a good start. The gas isn't on.
It's very quiet. Right, hang on. Do you want me to
It's testing yet. Turn it off. Miss forgot to put the gas on. Blame me. It was my fault. We're just testing the gas. That's why there was no gas coming out. Whoops. It's just testing. I put the fan on, but forgot to put the what's it? Right, gas is on.
Nice.
Let's try now.
Right. So gas is now on.
Now we can hear it hissing. Hey!
Right. Okay. So let's put this.
You've
on
just
the
blown it out.
Oh, you joking? Oh my gosh! Right.
Third time
What's
lucky.
the point in having me here today?
It's fine.
it's great.
At least you.
I thought I was going to be more helpful.
There we go. Don't blow it
I
out
have
again.
blown it out, have I?
No.
Right. Good. So.
Right. Put it on a blue flame so it's hotter. Okay. And then what's going to happen to the water?
Simple question, but what's the boiling point of water? What
You know,
temperature is it going
It's
to be?
funny you should say that's a simple question.
Is
We
this?
did this on Wednesday,
Yeah.
and no, they couldn't remember. Let's see who
You're
gets it
joking
first.
me.
No.
No.
Miss, what was your question?
What is the boiling point of water?
Let's
What
see
is
who
the
gets it
temperature?
first.
Is the boiling point of water?
Yay! Ethan got it.
Ethan got it first.
Ah, thank goodness.
And
Well
Sam,
done, Ethan. Well done,
100.
Sam.
So when this water gets to 100 degrees, what is going to start coming off the water?
Oh, this links to what we did. So it changes. So it's a liquid, because we were talking about water,
Yeah.
weren't we? And then because it reaches that 100 degrees, it will change, and that's when it changes state. And it will change
What will it change into?
a gas.
A gas, exactly. So that water that is getting hotter, so the particles are getting more energy. The particles are going to start moving around.
If you wanted to be super fancy, Miss, what would you say, beginning with a V, it's gone from water to water?
Oh, yes, and there's Sam. Sam's wrote steam or water vapour. Well done.
Brilliant. Well
Okay.
done.
So as this starts to bubble, we'll get the focus, you can actually see already. Can you see on the edge?
Yeah,
What's this? Can you see that white stuff?
Is that the salt?
That's the salt.
What's round here, Miss, as well on the
Oh,
side?
sorry, Miss.
Sorry.
Can you see all the salt?
Yeah.
So why is the salt not changing into a gas?
Does it have a different boiling point? Does it?
It has exactly. It has a different boiling point. At the moment, it's a liquid. Then it's turned into a solid. So the water is evaporating into the atmosphere.
So it's changing
And
back
then this,
to what it was.
yeah, exactly. It's changing back to what it was. So let's draw a little picture,
Cool.
and then we'll label. So first thing we need
Tripod.
is a tripod.
Oh, you're going 3D?
Okay.
I'm not going.
I went 3D.
I'm not going to. Do you have to? Do you want?
No, you don't have to. It's not an art lesson. I don't mind, as long as you label it as the right thing. So this is your tripod. Okay, your tripod. I started 3D, now I've gone 2D.
No, this isn't 3D.
let's make it 3D then.
Is this a heat
There we go.
mat?
This is a heat-proof mat, exactly. This is a heat-proof mat. Okay. On top of the tripod, oh, I can't draw. we have
That
something called, oh, go on then, miss.
it's a metal thing that I have to.
It is a metal. It's called a how do you spell gauze? Gauze. Called a gauze. This is quite a good drawing, actually.
No, it's not bad actually.
On top of the gauze, we have this white thing. It is not a bowl.
Evaporation dish. Is that what you called it?
Yes, brilliant.
I tried to remember when Miss said it. I was like, I'm going to remember that one.
Yeah, everyone forgets that one. It's an evaporation dish. Evaporation dish.
Okay.
I'm missing something.
Bunsen burner.
Bunsen burner. Okay.
Oh, that's detailed. I'm just going to draw it.
Yeah, a Bunsen burner. Where shall I put this, Aaron? Okay, last one. Bunsen burner. Okay, so that's. I'm quite impressed with that.
That's good.
Oh wow, that's looking good.
Yes.
Look at this now.
Really good.
Oh, that's easy.
And what's really interesting, what's happening is, because the dish is getting so hot, it's heating the little molecules of salts, and they're actually getting so hot that they're almost detaching from the side and falling back into the water. And we can actually see some of it.
Yeah.
Just there.
Yeah. So it's getting that hot, it's falling back in, and it'll fall in and then dissolve again, and then start all over again. Okay? So, whilst that's evaporating, we're going to write a sentence. So, evaporation is used to separate. Now, this is a different technique. What are we separating this time?
The starting ones. The solute and solvent.
Yeah, exactly. So evaporation is used to separate
The reactant. Is it reactant? Is that
if it's a chemical reaction, you'd get reactants and products, but it's not a chemical reaction because we're just changing the state of the products. We're not changing them. We're not changing salt into something else. We're still staying with salt, but it's just going from a liquid to a solid or a solid to a gas.
They are known as physical changes.
Yes.
Yeah.
Yes. So evaporation is used to separate the soluble solid, in this case the salt.
the solute? Is that the solute?
Yeah. The soluble solid. I'll put that keyword in. Well done, miss. Just the solute from the solution of liquid, which would be the solvent. You only use evaporation if you want the soluble mixture out. Okay? Really important. You would not use evaporation for this. Okay? If I want to take me some tongs, you get some tongs. I'll have a look. If I put that mixture on there, the salt would dissolve and it would go in with the water. The sand would burn. You can only separate soluble from the solvent in these. Okay? So evaporation is used to separate soluble, so the salt, from the solvent. So e.g. salt from salt water. Okay? Whereas here we separated the sand.
Yeah.
So filtration takes away the insoluble products.
It's not, but it's almost like it gets rid of like the bigger bits, isn't it? And then
Yeah, exactly. There's another one you would have probably done at primary school, which is called sieving.
Yeah.
So what you would do is you'd get a sieve to take away any bricks. Okay.
Yeah.
So if this had bricks, I wouldn't put bricks through a filter paper. I'd use a sieve. And then once I sieved it, I'd filter it.
And then you
Once
do
I
that with
filter
colours,
it,
don't you?
I'd evaporate it. Okay. There's the diagram.
This is looking brilliant.
Is it looking good?
Yeah, it's got so much salt.
Oh, wow.
That's
Yeah,
lovely.
turn that off
Yeah.
there, I think.
Turn that off.
I'll leave that
Got
there
loads of
for a minute.
salt. Where's all the water gone?
Gas, water vapor.
Yeah. So where's the water vapor gone?
Around, gone, up.
Where's it gone? Where's it gone? It's gone into the atmosphere, okay? Me and Miss aren't magicians. We can't make it vanish. The water hasn't vanished. It's just now a gas in the atmosphere. Water is still here, but we just can't see it. It's just a gas, okay? So it's turned into water vapor, okay? There's lots and lots of salt in there. So let Miss take that off, okay? And there's filtration and evaporation. If you are interested, you can do this at home. Okay, you can use your oven, not your oven, your hob. Put some salt water on your hob and see what you can do. Okay. Obviously, if you are using the hob, do not burn yourself. Ask your parents, but you can do both of these at home. You would just use your hob instead of a Bunsen burner. And there's all our salt. Lovely salt crystals, and they're hard. Okay, and they're very, very hard. Okay, and some have come off. If you look closely, let me see if I can get focus.
Yeah.
They're salt crystals. There we go. The salt crystals. Okay. Now the salt crystals. So I'll take a picture of these, put them on Instagram, and now we're going to go over to some maths. Thanks for that, Miss.
Yeah, thank
You're
you.
welcome, Miss.
Thank you.
All right.
Oh. Thanks for help, Miss.
You're welcome. Have a good weekend.
And
Bye.
you. See ya.
See you. Have a good weekend, Chelsea.
Bye.
Yeah, she says see ya. Miss says thank you. Right, probability.
Yeah, we're going to have a look at probability today. It's often a topic that people feel that they know a bit about, but maybe it's something that we don't do enough of. It's something that's often at the end of the year and sort of do it for a bit. People often get the basics of it, but not necessarily understand the complicated bit. So what we're going to do is go over the basics today, and it just means that when I do it on Wednesday, we can go over some harder ones, okay? So we're just going to make sure we've got all the basics. We haven't looked at probability since lockdown, so let's do some of this. Some of you might not have even done this at school yet if you're in year 7. You probably done it in primary school, but you might not have done it in secondary school. So let's have a go. What's important about a probability? What anyone got anything they know about probability? Any facts you might know that we could write down? Let's just throw some out in the comments. What do we know about probability? Any words, any comments, any sentences you know about it? Any facts? Miss, do you know any?
Is it always out of 100? Or is that percentages?
The percentage of you're close. It always adds up to something. It's not 100. Always add. Yeah.
1, 10, 1?
1.
1. So percentages are out of 100.
Yeah.
Probabilities always adds up to 1. Okay.
Yeah, and people saying it's how likely something is to happen. The probability is how likely something is to happen. Now, often I ask a question or you're sitting a test or something. Yeah, Sam said it's to do with fractions or decimals. Now, things add up to 1. It means we can use fractions or decimals. Now, we can't use percentages.
Because they add up to 100.
Yeah. Okay, so we tend to see them in fractions or decimals. Sometimes you might be seeing it as a sort of percentage, because you can change percentages, fractions and decimals, but let's just remember they add up to 1 and we use fractions and decimals for now. Now, that does mean people will have seen them, especially in primary school, using words like likely, impossible, things like that. Like, it is going
Very
to be
unlikely.
certain, it's unlikely, it's very likely. Yeah. And in maths, we tend to move away from that now. We try and give them a number. There is a number of something happening. So here's an example. And often questions will use spinners. Okay? Split it in half and then each one in thirds. So you end up with 6 even shapes. Okay, granted that's not even. And the question will specify this spinner is unbiased. What do you think the word unbiased means?
But everyone's equal?
Yeah.
Everything's equal?
Yes. So if it was biased, it'd be unequal. Maybe I could make something so Miss Edwards was likely to win. You know, something like that. Unbiased means it's equal. Or it's fair. Yeah, well done, Ella. Fair.
Yeah, well.
Okay. Now, I'm going to colour in some of these. Please colour in them. It doesn't have to be the same colour, but the same number. So, choose 2 colours. I'm using yellow and blue. But you can choose whatever colours you want as long as you've got the same number. If you haven't got colours, you could just write the word in. You could write B.
Or a symbol.
Yeah, anything. We just need to distinguish how many of each we've got. Now, if I ask for the probability of yellow, and that's how we write it.
And what does the P stand for? Probability.
P stands for probability. I want the probability of yellow.
Oh, I've wrote the word yellow, but mine aren't yellow.
Yeah. And I want the probability of blue. Yeah, so if you haven't done yellow or blue, replace these for your colours. Brilliant. Lucy's written a half. Why has she written a half?
There's 3. There's yellow, there's 3, so I've got a 3 out of 6 chance.
Right, and you've done it perfect. Exactly what I always say to people. Probability refers to how likely something's going to happen. So how likely is it that this spinner would land on yellow?
I've got 3 chances.
Brilliant. 3 of them are yellow. Out of 1, 2, 3, 4, 5, 6. So that's how I always do probabilities. We'll write this out in a minute, but I always write it out. Top one is what I'm interested in, bottom one is total outcomes. Can I simplify that?
Yes, because Lucy said so.
They both.
What goes into 3? 2.
3 does. I keep.
Oh yeah, 3 does.
3 goes into both
3
of them.
once.
No, it doesn't matter which one you use. I haven't asked for the simplified fraction. You could leave it as either. But it does also mean you could write it as 0.5.
And either would be correct.
Either. It still says there's half a chance. So what about probability of blue?
Well, there's 3 blue, so 3 goes on top.
Out of
There is 6 altogether. It'll be the same.
How could I have worked out it was the same, even without the picture? What do probabilities have to add up to?
1.
So if I've got 3 of them are yellow, the other 3 have to be blue, because it has to add up to 1. 0.5 add 0.5 equals 1. If you had 3/6 of a pizza or half a pizza and you put another half a pizza together, you've got 1.
So is 3/6 the same as saying a half?
Yes.
So if I got a half of a pizza, I could cut it up into 3 sections.
Yep. So if you had half a pizza and I had 3/6 of a pizza, we've got the same size amount of pizza. I could have 100. I could have 100 slices out of 200 slices. As long as it was the same pizza I've cut it into, I've got exactly the same as you. It's the same number.
With you.
Okay, let's have a look at another one then. Oh, let's do a summary actually. So to work out a probability, what was it we did for the fractions? The top number was...
Is what we want.
Yes, I'm going to call it interested outcome. Outcome is just a fancy word for the thing that's happening. So if I spun a spinner, the outcomes would be yellow or blue in this case. So the ones I'm interested in, divided by what number was on the bottom?
The total.
Yeah.
Top number is what we're interested in. The bottom is the total.
So it's what we're interested in divided by the total. Okay? Right,
Yeah.
let's have a go at the second one then. What we're interested in divided by the total. So here's another spinner. I would like this into 8s. Best way to do it, straight down the middle, straight across, so you're in quarters, and then do your diagonals. And you get 8 reasonably even. Right, again, you need 3 of one colour. I'm doing 3 yellow.
Doesn't matter which 3, as long as there's 3.
Because they're all the same, because we said they're unbiased, they have equal chance of landing on any of them. Doesn't matter which ones. There was 2 blues.
Oh, we've got more colours.
Got
I'm going to have to do some
greens,
stars.
and I've done 1 pink. Now, I'm aware that you might not all have these amount of colours. You could just write the word pink. You could just write the word P, letter P. You could do a star, smiley faces. So remember, it was interested outcome divided by the total outcome. So that was our fraction. Bit on the top was interested, bit on the bottom was total. So I want to know probability of yellow, probability of blue, probability of green, and the probability of getting a pink one. So this is a spinner. It's going to spin around. What's the probability of getting a yellow, blue, green, and pink? So put in some comments if you think you know any. So top number is what we're interested in. The bottom number of the fraction is the total outcomes. Fantastic.
I'm having a nightmare here.
So you don't have to
My
simplify.
colours are not the same as you.
Yeah, I appreciate it. It's
so
hard.
bear with me. Right. So purple. Brilliant.
So the first one, there are 3 yellows. So I'm interested in yellow, so that goes on the top. There's 3 of them. And the number on the bottom is how many there are in total. There's 8 this time.
Oh, there's
Now,
concentrate.
it hasn't asked me to simplify, so I'm not going to. This one actually can't be simplified, but I'm not going to. Blue.
2
Out of
8.
brilliant. Now people
we can
have
simplify
simplified.
that.
Yeah, you can. You halve both numbers, you get 1/4. So half the 2, half the 8.
0.25. Yay.
Josh, be careful. You are correct when you simplified. Yeah, well done. 2 over 8. This is equal to 1/4. So green. How many green ones are there, miss?
2.
How many are there in total?
8.
And we know that that's the same as a quarter. Fantastic. Oh, great. Putting them all in at once. Brilliant. Pink, well done. There's 1 out of the 8. That can't be simplified. How can you check you've got it right? What is there you can do?
Make sure, well, there's 8 pieces altogether.
Yep.
So we need to make sure the top numbers add up to 8.
Brilliant. If the top numbers add up to 8, then I've got 8 out of 8, which is 1 whole bit. 3, 4, 5, 6, 7, 8. These all add up, so I would get 8 out of 8, which is 1 whole number. Fantastic. Okay, just so I'm going to write check. Total equals 8 out of 8. And that equals 1, as we know. Fantastic, guys. So this is how probability can start. A lot of people get confused because they just don't understand some of the wording of it, but really it's not that much harder. You can get questions, and the exams like to do this, where they give you a fancy jar, or they say there is a bag of marbles. Okay? I want you to draw 1, 2, 3, 4, 5, 6, 7, 8, 9 marbles. I want 4 pink. So you could write P in them, or you could write pink. It's up to you. You could 2 yellows. And the rest of mine are going to be green.
Gotta keep mine white.
Yeah. Okay,
So
I want
probability
probability
pink.
of yellow. Oh, I've changed my order.
Probability of pink. Probability of green.
You remember to use your own colours.
Yeah. I wrote green again. Ah. With it. Done. Oh, green or pink?
Yep, I've got 5 questions now. Probability of yellow, probability of green, probability of pink, probability of picking a green one or a pink one, probability of picking a blue one. Fantastic. Lucy's given me them all in one comment. Excellent. Has anyone else managed to get them? Do you agree?
I'm still
Do you
writing the
disagree?
questions. Probability. What does that say? At the
Blue
bottom,
at the bottom.
blue.
Blue.
Blue?
Blue. Yeah.
There isn't any blue.
So what's the probability of picking one?
Oh. Oh, it's been a long day already. My brain's asleep.
Josh has done the same at home. Right, we've got Lucy commenting answers. I haven't seen any other answers. I'm sure you're doing
Sorry, pink. Probability.
Right, I'm going to go through it. So probability of yellow. There are 2 yellows. That's what I'm interested in. So there's 2. Fantastic, Jacob. And there are 9 in total. So it's 2 over 9. Now, if you simplify them, it gets hard to check you've done it right. Okay, so I tend to just leave it unless it asks. Probability of green. Well, there are 1, 2, 3 green ones out of 9. That could be simplified to a third.
I know what this is as decimal.
Go on then.
0.333 recurring.
It is.
I remember that. You taught me that, miss.
Learnt that. Well done. I'll put that on now since you've mentioned it. Okay, probability of pink ones.
4.
Perfect. There's 4 out of 9. Well, they're all the different colours. Let's just check. 4, 5, 6, 7, 8, 9. Perfect. There's 9. Adds up. So we know we've got that done correctly. Slightly different one here. Probability of picking a green one or a pink one.
So, what? Green is 3.
Yep.
There's 4 pinks. So do you have to add them?
Yeah. Because if you think about what probability is, like Lucy said at the start, it's how likely it is you're going to pick out that thing. Okay? You're going to pick out. So I'm talking about whatever these are, marbles or sweets in a jar. Okay? What's the probability that you're going to pick a green one or a pink one? Doesn't matter which one, but you're going to put your hand in this jar and you want to pick out a green or pink. Either of them. It doesn't matter. What is the probability of that happening?
Green, 3.
So I'm interested in green or pink. So 1, 2, 3, 4, 5, 6, 7. Yeah. Green or pink.
7.
It doesn't matter that there's now 2 things, but I'm interested in green or pink. So I add them, and there's 7 of them, and there's still 9 in total. Another way you could have done it is it all adds up to 1. Okay? You don't want the other ones, so you could take away 2. 9 take away 2 is 7.
Okay.
Yeah? Okay, what's the probability of picking a blue one? Confused a couple of you. Some of you are like, well, there aren't any blues. So what's the probability of picking it out, miss?
0.
Yeah. 0. Just 0 will do.
Just 0.
Like, there are no blues. You can't pick it out. Like, it is 0. Okay?
Okay.
Likewise, you could write 0 over 9. It's exactly the same thing. Likewise, I guess if you had, here's a little extra. If you had a bag, 4 marbles, and they're all green, and I asked what's the probability of picking a green one?
Four out of 4.
Yeah. Well, there's 4 of them out of 4. Well, 4. If
Which
you have
is
4 slices out of 4,
you
how
get one
they've got the whole
whole.
thing, because
Oh, I
probabilities
like
add
that
up to
idea.
1. Probabilities go between 0 and 1. If you haven't got any, probability is 0. If you've got it
I like
all,
that.
the probability is 1. Okay, so that's the range of it. If you haven't got it, it's obviously 0. If the only option is green, then the probability has to be 1. All probabilities are out of 1. Okay, and that's why when you've got different amounts of things, they have to add up to 1. If you were using words, probability of picking blue, you would say it's impossible. Probability of picking green, certain. But instead of using those words, if you think something's impossible, like blue, put 0. If you think something's certain, put 1. Okay? And that's just the difference now.
Yeah, look at
Right.
that.
9 minutes, and this is a question that everyone just gets wrong because they just don't. They're not familiar with it anymore. So let's have a look. Question 4. Pack of cards. A standard deck pack of cards, and you'd be surprised how many people don't know what a pack of cards is. What's in it? Oh no, you're not. Really? Oh, fair enough.
I'd have to write them down and do some maths, but
Yeah,
there's
people don't know what suits there are. They don't know what colours there are. They don't understand them. And honestly, it's fair enough if you don't. That's absolutely fine. I can understand how people nowadays don't use them, but they are in a lot of questions. And I mean, I've sat and played card games with my family.
2 colours.
Yeah, there's 2 different. We'll go through it now. There's a board in the maths corridor that actually explains a bit about them as well. But let's go through it. So let's work out what there is a pack of cards. Does anyone know how many there are?
Not without adding it all up.
In total, there are 52 cards. Okay, there are, from that, 4 different types of suits. Like I said, some people will know this, some people won't. Let's just work it out.
Hearts is one.
Yeah, someone's just said there's 54. There are 2 joker cards. You don't play with them. So it will say standard pack of cards, and it's 52. Yeah. Some people play card games, some people don't, and it just depends.
I play Snap.
Well, even that will get you familiar with them.
Yeah.
There are 4 types. So, Miss said there's one called hearts. What colour do you reckon hearts is, Miss?
Red.
Yeah. Perfect. Well done, Luke. The next one, let's look at diamonds. And they are also red. You have clubs, which are black. And you have spades, which are black. Okay.
So half of them are black, half of them are red.
Perfect. Well done, Miss. For no, half. Okay.
Yeah.
2 out of the 4 are black. 2 out of the 4 are red. So half are red, half are black. Now, we're splitting 52 cards equally into 4 groups. What's 52 divided by 4?
13.
Yeah. So each thing has 13 cards. So each, and we call them suit, has 13 cards. So there are 13 hearts, 13 diamonds, clubs, spades. Fantastic. But even if you didn't know that fact, you can work it out. Your 52 cards are split into these 4 suits. So each of them have 13 suits. Does anyone know anything about the suits?
There's a king. There's picture ones.
Yeah, there are. So your 13 suits consist of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 of them. And there's 3 more, the picture ones. So Miss says there's a king.
King. Queen.
Yep.
And a jack.
Yes. They go in order. So after the 10 is the jack. After the jack is the queen. And after the queen is the king. Some people call them number 11, 12, 13. Okay?
Would the 1 be your ace?
Yes. 1 is also sometimes called an ace. That's a good point.
Yeah.
So ace of spades, people, I guess, is most heard of. people might call it. So you've got ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, which is jack, queen, king.
Yeah.
So can be complicated, but questions, and Miss said this, these three are pictures. They've got pictures of people on them, those three. So a question might say,
Come on, let's do this.
what's the probability of picking a red card?
Well, I know there's 52 cards, so that would be the bottom number.
Okay, so how many of them are red? So we're interested in just the red ones.
Well, there's 13 red hearts,
Perfect.
13 diamonds,
Perfect.
13 plus 13, 26.
Yeah. Now, you've worked that out
Which is
perfectly,
four.
but you've said already, well, half of them are red.
Yeah.
So you could have just written a half. No, that's right. 26 cards out of 52 are red. There are 2 jokers, Sam, they are, but they're not in the standard pack of cards. You get them in the box, but you don't count them in this, okay? What about probability of black and a picture card? So it wants to be a black picture card. So the way to work it out, clubs, there are 13 cards. The only pictures that are clubs are the jack, queen, king. Jack, queen, king. So that's 3. Yeah? 3 clubs. But you've got to remember, spades also have the jack, queen, king. So why am I not looking at these 2? Well, they're red.
They're red.
Ace isn't a picture, no. It's just these 3. So clubs has 3 pictures. Spades has 3 pictures. How many pictures is that altogether?
6.
Out of 52. What's the probability of getting the 10 of diamonds?
Well, there's only 1 10 of diamonds.
There is only 1 10 of diamonds. So that's 1 out of 52.
So pretty.
You're in the diamonds. There's only 13 diamonds, and only 1 of them is a 10. You haven't got more than 1 10 that's a diamond. Okay? So it's just 1 out of 52. And the last one, probability of picking a 4. What's the probability of picking a 4? Right, I've said it before. We don't count the jokers when you're looking at standard packs. So just ignore them. People get confused with them. Ignore them. So what's the probability of picking a 4?
There's a red, 2 red 4s.
Yeah, there's a 4 of hearts, there's a 4 of diamonds, there's a 4 of clubs, and there's a 4 of spades. Each one of these 4 suits has these. So there's a heart, diamond, a club, and a spade. That's 4 of them out of your 52.
Yeah.
Yeah, can simplify to 1 out of 13. Why does that?
Oh, who did that?
Ellen.
1 out of 13.
1 out of 13 because it's one of them's a 4 out of the 13.
Oh,
It's split into
clever.
4, but out of those 13, only one of them is a 4. So this is hard, and I think Lucy said it. How am I meant to remember all this in an exam? Like, what if there's only one question and I have to sit there and work it all out? Key bits: 52 cards, hearts, diamonds, clubs, black. If you can remember red for these 2, black for these 2, you'll be fine. Okay?
Yeah. Ace. Go play a pack of cards with your family.
Yeah, just get them out. Play, like you say, snap or something. It doesn't matter, but
Snap.
you get familiar.
Yeah. Go play, or make a pack of cards if you haven't got a pair. You only need 52 pieces of paper. Right, thanks, Miss.
Yeah, thank you.
Brilliant. I'll see you tomorrow.
All right.
Bye.
Tomorrow, isn't it?
Yeah.
Yeah.
Bye.
Well done.